All right, hi everyone. Welcome to ACORD sprint number 6, or I think it's number 6. So in this sprint, this was a 3-week sprint. We accepted 176 stories. Somehow we only managed to add 2 stories, not 2 story points. Sorry, that's typo. Throughout the entire 3-week sprint, which is really quite impressive. That's good. On the other hand, we only fully completed 80 story points, which is a little less than 50%, which is not great. But the silver lining, once again, is that we have 54 items in progress, which means that we took on 176, but we worked on 134, which is pretty good. And 42 were unstarted. I haven't had time to look through the stories, which ones were the ones that were not started. I don't know how consequential or relevant they were, or where they came from, or how they were. So I'm not too super worried about that yet. But so that's pretty good. So it seems like things are moving forward faster for the sprint, for the kind of last sprint that we have. So with that, let's move on to the OLT and multicast. I also threw in there that the pod build out at ON Lab is complete. We're trying to, well, we build it out. We're putting the software on all the elements, and we're putting the software on all the elements, and we're trying to keep the pod as clean as possible. So when we wire things, unwire things, because we're still don't have end-to-end connectivity. We just have to test individual elements. We're trying to keep it as clean as possible, but other than that, it looks good. I should have probably stuck a picture of the pod in here, but I didn't. Anyway, on the OLT, there are only just minor fixes to the OLT application, mostly revolving around events and stuff like that. But otherwise, the OLT application is in good functional state. The IGMP application now shares configuration with the OLT application, since those two applications just need to know who the access device is and provision them with default rules. The multicast tests are underway, so Jono and I have been kind of looking at that a little bit. The problems mostly revolve around getting the set-top box up and working correctly. That's been a little challenging. Hopefully this will kind of settle down and we'll do better. And there's a REST interface to sync multicast routes with the Fabric ONOS, so the Fabric ONOS knows what multicast routes to forward. That's a bit more forward-looking, but it's good that we have that.
Ali, before you jump off the slide, first,
yeah,
for the great news that the pod build-out's complete. As you're making changes based on facts on the ground, as they're changing, trying to get the thing up and running, are you adding that information to the Google Doc?
Which Google Doc are you referring to?
The pod build-out Google Doc that you've been that was started.
No.
Hey, can you guys hear me?
Yeah.
Yes.
Hey, Ali, this is Bruce. So I've been doing some more testing with the OLT, and I wanted to just share a couple of the things I found with you real quick.
Sure.
So I can get Q&Q to work, and I can get the authentication to work. The problem I'm finding is the rules are not compatible. So if you have both the authentication rules in and the Q&Q rules in at the same time, then things don't work. So I've been able to verify that using OF tests as well.
So can you just say again? We lost you for a bit there.
Okay, so I was saying that the authentication rules don't seem to be compatible. In other words, if you have the authentication rule in for a port, like say for port 130, and then if you have the Q&Q flow rules in for port 130, then the downstream flow doesn't work. And also the authentication stops working. Now you can get around the authentication problem if you wrap the ePOL message, the authentication message, in a VLAN 0, tag it with VLAN 0, then that will start to work. But I found no way to get the Q and Q to work as long as there's the ePOL message in. So then I tested when you instantiate the Q and Q flow, if you remove the authentication message, everything's happy again. So
here's the thing, Bruce. You need to wrap the EA-POL message in a default VLAN.
good, that's fine. Then that fixes that, but that doesn't fix the downstream Q and Q.
The downstream Q and Q does not work when the EA-POL rule is there?
Yes, that is correct.
Huh. Okay. All right. Well, I'll have to test that because that's a regression then.
So, I mean, we've done it here about 20 times today, and then as soon as I removed it, and the fix is easy. If all you have to do is remove the ePOL at the time you set up the Q and Q. The only other, and so that's what I'm doing now. I coded it to do that, and everything seems to be happy now.
So if you have that code ready in ONOS, then please contribute it, because if that fixes it, then if it's a workaround for now, and then I can talk to PMC in the meantime.
Yeah, that's fine. And I was just sending you an email on it. So.
Okay, great. Thank you. Thank you. That's really great. That's good. Albeit strange, but good. Cool. Thank you. Any other questions on the OLT and multicast and pod build out? Nope. Okay. Let's move on to Core VTN. So Hilton, go ahead.
I added local
Ali, we've lost audio, and I suspect you can't hear me say this.
Well, it's good to know that I'm not the only one.
Yeah, me too. It makes me feel good having company.
They were having audio problems on an earlier meeting too.
Yeah, we just should have our own meeting. Yeah, something is wrong. All right, that's good. They know that.
That statement's pretty good anytime, anywhere.
There you go.
Can you hear us?
I'm tempted to have us all stay silent just to confuse you, but I can hear you now.
so you can hear us, right?
Now I can, yes.
Yeah,
Okay.
I think the mic cables. Just
Yeah, I think we use a microphone here, and it's possible that our yeah, don't touch it. It's possible that our USB wire cable is gone old. So I guess Hilton,
I have a quick question. Where's the link to this presentation?
it's on the email on the ACORD mailing list.
Oh, ACORD mailing list. I'm on that.
Okay. Well, we can send it to you.
Okay.
I think you should repeat. Yeah.
Sorry.
No worries.
For Core VPN, I added local management network connectivity. So now VM with management network is now reachable from compute node. And I also added the bidirectional connectivity option to service dependencies. So if you add a little b into the service dependency post API, the two services can talk to each other. And also automated assignment of BRINT addresses, and you can check what IP address is actually assigned with the Core VPN node check CLI. And also, it's now everything's are automated for compute node bootstrap, so no more manual jobs are left. And I also built a cloud lab test environment, and I resolved some issues I found there. And now I'm still working on VSG connectivities now, and I think this is the last thing left for Core VPN.
Okay. Yeah, great. I also should say that I built out a small setup of Core VPN on my laptop, and it worked. And the deployment was quite smooth. The only issues I had were OpenStack issues, so that's a good thing. It's quite nice. It works really nicely. I have to say, it's really great work, really fantastic work. So
one question.
Yeah.
So automated assignment of BRINT address or the VTEP address you are talking about?
You can specify the addresses in the network config.
So that is the VXLAN VTEP address.
So
right?
what happens?
Not the VM address.
No. So what happens? It's the compute interface address. Compute node interface address. It's a data port, essentially, the compute node.
Okay.
So what happens is your compute node is connected to the data network, right? May or may not have an IP on the data network, and you spin up Core VPN. And Core VPN then by configuration knows where the compute nodes are, right? And reaches out to the compute nodes and provisions OVS how we want it to be provisioned, as in with a VXLAN port, with an IP address on the bridge on the BR end. And all that stuff, and it manages it all and puts it all in place. Now the nice thing is as well, like if this has already happened, right, and you reconnect Core VPN, right, it doesn't do it again. It doesn't go into some crazy state. It just looks at it, looks at the OBS, and says, oh, it's already good. Okay, so it's quite nice. The degree of separation between VTN in ONAS and neutron state is nicely separated, that you can restart ONAS independently, right? And things will still work because the metadata for your network is all stored in neutron, for better or for worse. That's a different discussion that we can have, and some people will freak out about this. But the good thing is that, like, at least we don't have to worry about like maintaining state in ONAS that we have to persist anywhere. It's all in neutron, and we're going to go fetch it and then provision the network, which is really good. At least there's one source of truth for that element. Whether that source of truth is the right source of truth is a different debate that we can have over beers or something. But not now, please. All right. Any other questions about VTN? Nope. Okay. So let's go on to the fabric.
So right now the fabric hardware, okay. Right now the fabric switch and the computer, they're all moved to a new rack, and also the workaround for OLT is merged into the master. And I also implemented the public route between BSG and vRouter. It's already in Garrett and it's waiting for review. And right now I'm working on vRouter segment routing integration. And also I think Fabio is working on the test automation for segment routing. And Ray, do you want to give an update on it?
Yeah, so one of the things that I did during this sprint was add we're calling the network config link provider. So essentially what this is a data center oriented topology where you specify ahead of time all the links that you know you want to exist between your devices. And rather than using LLDP to discover the links like we normally do, what we do in this case is we predefine those links based on the configuration and only use LLDP to determine if the link is up or down. This has two properties that are nice for data center type people. One thing is they can define ahead of time what they expect their network to look like. So if things are miscabled, the UI will tell them, we'll show you a demo of this in a little while, the UI will tell them via visuals whether the link that was discovered via LLDP is actually the link that was defined into the system. And the other thing that it does for you is it gives you a way of using only part of your network. If you have links that are there but you don't want to use them, if they're not in the config, they'll never be used by the path calculation algorithm. And here's, we did a...
Yeah, no, I'm not showing it now.
Sure.
I'm trying to copy it. But
Or you can, before you show the demo video, do you want to go to the slide?
Yeah, hold on. I'm not showing it. I'm just.
Okay.
I'm just
He's trying to insert it, I think.
I'm just trying to download it.
Or you can just play it on the YouTube.
Oh, okay. Well, anyway.
Switch to YouTube.
Okay.
So we'll have a demo of this in a little while where you can see what the config looks like and how to use it.
Can I ask one question?
Yeah.
So if LLDP discovers a link and it is not present in the config, we don't process that link?
We create a link that is marked as unusable, and so it will show up as a red line in the UI.
Because in the segment routing, when we started, we went with this approach of config-based link detection, but that inherently has prone to more errors where operator needs to feed each of the links in the network, right?
Right.
Yeah. So here's the thing, right? Like, so yeah, you're right. Like typing the topology is error prone.
Yes.
Right. Like for sure, without the shadow of a doubt. The point is that like usually when you deploy a large network, and okay, granted, CORD right now the fabric topology of CORD is rather small, but in the fullness of time it'll get bigger and bigger and bigger, right? And the thing is that like you usually in like a deployment network in an operational network, you've used some tool to draw up your topology, right? You can use that tool to then generate the other config. So there is no human interaction there. That's in the fullness of time. Right now, we have to type it in, right? We can automate it to some extent, or make sure we get it right. For small, we only have four switches, right? Not a big deal, right? But I agree with you. Yeah, typing it is error prone, but in the fullness of time, you have a tool that generates that config file that then gets injected into ONOS. Right.
Yes, that is one problem that we detected. The second problem we detected was if you have your segment routing working on this based on config-based links, what we ended up creating a two power the number of links, that many number of groups we are creating in each of the devices. Because now, suppose if I have a 2x2 matrix, leaf spine. So at each leaf and spine, or at each leaf at least, I create the group tables.
Yeah.
Those many links that I configured in the config file, even though those links were never used in the path calculations or.
That's a separate thing, right?
No, we don't want to create upfront all these large number of groups in the switches. We actually moved away from that link-based, config-based link detection, and we thought of as in when the link's discovered, you create your group tables and push it to the devices.
Oh, you're saying because all the links get injected at the same time, and therefore you create all the links at the same time?
And we take permutations and combinations of for each device how many links are originating, and we create those many number of groups inside that device. Because you can have ECMP paths, right? You can take link 1 or link 2 or link 3, link 4 or link 1, 2 or link 1 to 3. So all these permutations and combinations of groups we upfront create and push it to the device, though not all of them may never be used in the actual forwarding.
Wait, I think we only pushed the group when we detected link added.
That's what. If you go with this config-based link, I believe
the link only gets added when the LLDP responds.
But
if I configure in the
hold on. So the way it works, right? You have a configuration that specifies your topology. That gets put into ONOS, right? And ONOS says, okay, this link is configured, not active, right?
Okay.
And then we send LLDPs down those paths, right? And say, oh, the link is here. It gets added. It gets set to active.
Still rely on the LLDP discovery to make it as
because it's not there.
Okay.
So configured links will show up in the UI.
Yeah.
because they're actually in the internal database that ONOS is keeping. But like path calculation doesn't know about them yet because they're never active.
Right.
Then
Yeah, the whole idea, there's now a state machine that is associated with the life cycle of a link. And I mean, this is kind of, you'll see this is kind of useful for other reasons as well. So for example, for VTN, if you take VTN and you have each compute node has an OVS, right? And we create service dependencies, right? There is no topology discovery happening because the pipeline we have on our OVSs doesn't know how to slap a VXLAN header on an LLDP packet and send it out to the right other compute node. And also that would be clunky and complicated and it doesn't bring much value. With something like this, we can inject the links. Right? We can inject the links, say, oh, we've created a service dependency between these two services and therefore these compute nodes. Let's create links for them. So then the UI can show you kind of like a mesh topology of the compute nodes as they're being created, which is kind of handy for debugging purposes, because then you're like, okay, we actually receive that service dependency, right? Therefore, the service dependency should be installed. Therefore, traffic should flow. If it doesn't flow, then we know that there's something wrong in our forwarding data, right? Which is kind of handy, and we'll see a demo of all this in a bit. Okay. So, any other questions about this? Guess not. vRouter, Jonathan?
Yeah. So the sprint I set up a vRouter instance, basically pairing with the AT&T setup in Atlanta, and so we're able to learn the routes from there, program them into ONOS, and program them into the NoviFlow switch that I'm working with right now. Hopefully soon we'll be able to transition that to the fabric when Charles is finished integrating vRouter in the fabric. And yeah, so for Unicast we seem to be all working well. And then the other thing I've been doing this sprint is working with the multicast implementation. So the ability for ONOS to be able to speak PIM upstream to be able to join multicast groups. So I've been working with Rusty from DirecTV on making some improvements to the application that he's already written. So we can now periodically send hellos and form neighbor relationships with the upstream router and manage the neighbor state based on the hellos that we're seeing. And we're currently working on finishing off code to be able to send PIM joins to that upstream router. But I have tested this manually, so I know that I can send PIM joins and receive the multicast stream back. And then the final thing is that Ali and I have started working on an end-to-end test setup for multicast. So set-top box talking to an RG or a fake OLT, the vRouter, and then talking upstream to the AT&T router. So we're trying to work on getting that set up right now and working end-to-end. So yeah, that's all.
Cool. Any questions? Cool. All right, XOS guys.
Yeah, so we've been working. Andy's primarily been working on building up the software stack on the pod. So he has installed one head node and one compute node, and brought up XOS on the head node and VTN as well on the head node, and he's been able to bring up a compute instance, and the compute instance properly configured with VTN, and I think he's also tested management connectivity. So that's all going according to plan. He's building up a configuration that documents, his process for installing that software. On the VTN integration side, we've integrated the latest VTN under Cloud Lab. That was as of yesterday, so it has the latest changes for the BR-int management and stuff like that. We have management network connectivity all taken care of in XOS, so you can assign the management network to an instance, and it will plumb that through on the compute node, and then we have our SSH hopping solution in place that lets the head node SSH into the compute node, and then SSH over the local management interface into an instance to configure it. We added the ability to create XOS networks with specific subnets. So this comes in handy with the management network, so we can assign it a specific subnet rather than XOS just picking a random subnet for it. And then we also have automated the Neutron VTN plugin install and configuration with the Juju Charm. That's part of Andy's configuration system to automatically bring everything up. We've renamed the VCPE to VSG in visible places in the XOS UI so that we won't be confusing people anymore. For ONOS as a service, we've added the ability to manage ONOS on the head node, so we don't have to have ONOS brought up in an XOS instance. Someone else can bring it up externally, and then we can manage the configuration of that ONOS. For the open cloud deployment, we're finally having good success on that. We have the Princeton and Stanford clusters fully operational. We've brought up the CDN on those clusters, and we have redirected the CDN that was serving the ONOS download links, so it's now being served completely by the new clusters. And installation is in progress in Arizona, Hawaii, and UNC. And that's it for my portion.
Okay. Do you know when we'll be able to spin up a VSG on the compute node?
My hope would be that we can do it next week. So we're pretty close. You know, we need those the last bit of VTN stuff to implement the LAN side and WAN side connectivity, and then once we have that, we will modify our VTN spawning recipe to connect into that, and then I think we'll be there. So it remains close. It's just not there yet.
Okay. Do you think? I mean, it won't happen Monday.
No.
No.
Well, the first thing we need is the VTN stuff. So Hyun-Sun and I are iterating through the API that we will use to configure that. So I mean, it depends on how quickly we can close that API and get that implemented, and then we'll I would hope sometime midweek. I mean, there's not a lot left to do.
Yeah. It's just the earlier the better, because we have the Plug Fest, and I really wanna be able to have something up and I want to have end-to-end connectivity up and running here before we head over to Atlanta, where we're gonna build it again.
Yeah. That seems very doable to me, and we're rushing as fast as we can. We have that goal primarily in mind.
Okay. Yeah. We need. Yeah. Okay. Sounds good. Thank you.
Ali, before you go on, this is just an FYI because it doesn't relate to any of the stories that we have on the board. But there is now a set of AT&T engineers that are building the ACORD management layer that will sit on top of ACORD and integrate eventually into eComp, but at least in the short term into their existing OSS BSS. So there is progress not visible to anyone else on that front. Very early progress.
Okay, sounds good. All right, that's cool. Good to know. Okay, any other questions? Nope. All right, the GUI, Mateo's not here today, so he asked me to cover this for him. So I'll try to do my best. Or do you want to do it?
Okay, he sent me also a note. Maybe others can read it.
I can. He sent me a note, and I can just read the note because I don't do UI. But sure. So he took on 20 story points and closed 15, which is very good.
Yeah.
And so he fixed cord 499, 529, and 527. Which were small UI bugs, and for the subscriber portal, he moved it into the XOS source tree as an example, and refactored it to be used as a base for the other demos like ACORD and MCORD. The Ceilometer dashboard. You wanna cover that part? The Ceilometer dashboard.
Yeah. So even on the subscriber portal, this is what we have demonstrated in the last year ONS. So now it is moved into the XOS repo officially, and he made the refactoring so that it can be extensible for the other MCORD and ECORD demos.
Okay.
On the accelerometer side, yeah, we have identified some performance issues in displaying various metrics that we are correcting in the CORD environment, and so we did some front-end and back-end performance optimizations. So that is the activity that he's reporting here. On the diagnostic view side, we are planning to create a subscriber troubleshooting view that will display per subscriber level what is the service chain that is associated with that subscriber, and various troubleshooting metrics associated with each element in that chain. For example, it will show you the compute and storage and network related measurements for each VSG container associated with that subscriber. So he said only partially he could attempt that in this sprint, and the rest is for the next sprint.
Okay.
And the last one is for some testing information for his setup.
Okay. All right. So I think that covers basically the UI part. If you want to ask questions, you can. I don't know if you get them answered. No? Okay. So Srikanth, ACORD?
Okay, from the monitoring service side, so in this sprint we have finished implementation of S-Flow collection as a service inside XOS, and I have validated, I have validated that with the Inmon's sample S-Flow test application. So I use the VBNG OBS switch that we have in the Cloud Lab CORD config, that injecting some S-Flow data into the XOS S-Flow service and getting notified to the sample S-Flow application. It's working. I wanted to actually showcase some demo, but my setup is broken.
Wait, what did you use to generate the S-Flow diagrams?
Yes.
What did you use?
Oh, sorry.
What did you use to generate S-Flow?
So I use the Cloud Lab CORD config, so it sends the ping packets from the client VM to the internet. So the VBNG OBS generates the S-Flow.
Okay. So you're using S-Flow, you're using OBS to do S-Flow?
Yes, yes, correct. And the XOS S-Flow service collects them and then notifies to all the tenants, and one of the tenant is the Inmon's S-Flow test application. So it was getting the events and showing some graphs.
Okay.
I wanted to show multiple tenant applications, but yeah, anyway, I don't have the setup to show all those things. The second activity is we integrated the VOLT metrics into the monitoring platform. Currently, we have very basic information of whenever VOLT device is connected or disconnected, we are getting some events, and I could not verify the subscriber attach and subscriber unregistered events, but the necessary plumbing code is there. And the last one is we have done some explorations on the Siloska OpenStack project, as we came to know that Siloska promises some very good performance over the accelerometer, at least in the querying side of the functionalities. So we struggled with the installation of the Siloska and Monaska for almost like more than 2 weeks, and we felt that it is obviously not ready for our usage in the ACORD. But we'll continue our explorations on these projects, and we'll keep an eye on them so that eventually they are very good next steps for our ACORD project. From the in this sprint, we have found some issues with the connectivity inside the pod or inside the residential CORD pod. So we need to have some workarounds built for this connectivity between various accelerometer components running on the head node and inside the virtual machines on the compute node. We wanted to explore either SSH tunneling or some kind of BR management bridge connectivity to the virtual machines temporarily. Similarly, if we wanted to integrate this ACORD with some of the ONS analytics application, we wanted to demonstrate in ONS like anomaly detection and mobile CORD ESOM. Yeah, that's all I have to report.
Okay, cool. Thank you. So I think you can show a demo. Who's gonna
ready to run it?
No, you can do it, Charles. It was your demo, so.
Okay. So the figure on the left-hand side shows the current topology of the CORD rack at OLT Lab, and So so right now you can see we need Ali.
Yeah.
I need
sorry.
something on that.
Sorry.
Don't. Let me finish first, okay?
Okay.
I need a configure. So if you want to enable the
There's a
network
link
config,
to use it.
yeah. So if we want to use this network configuring provider, we need to enable this as an app. So you can see we put this in on this app. And also on the right hand side shows the network config JSON file, and we need to put link discovery mode to strict in the core app configuration, and we also need to specify which link we want to use. So, for example, the blue one on the left side, which connect the spine 143 to lead to port 1, is so we have configuration for bi-direction. So yeah, so I guess we can move on to the video.
Let me just.
So right now we can see the port 3 of spine 1 is connected to the leaf 2, and then I unplug the wire, and you can see the wire disappear on the UI. And then I plug the wire to a wrong unconfigured port, which is port 5. You can see a error condition on the UI, and you can see this link right now connected to port 5. And then I remove the link and plug it back to the right port. You can see the link go back. I think that's the demo. And also, when you plug the link to the wrong port, you can see the link in the link store, and the link will be marked as inactive.
Yeah, so for links that are marked as inactive like that are displayed in the UI, but are not eligible for traffic. So the pathing algorithms will not use them to actually send data.
Cool. And we have a little picture. I don't know if you guys have seen this. This is our pod at ON Lab. I don't think I need to describe all the elements to you, but that's the pod. It's all wired up and ready to go. We just need essentially one more element, and we're good to have end-to-end traffic. We can already pass traffic all the way from a home user into the node into the compute node that would run the VSG, and so we go from the end user through the Xavi RG to the through the OLT into the fabric, out onto the compute node, which would eventually go out of the compute node back into the fabric and out to potentially a service or to the internet. So we just have that one little step missing. We were hoping to have that little step ready by today and do an end-to-end demo, but we're very, 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 very freaking close, and we'll do it. So with that, that concludes the core sprint. Anybody have any comments or questions?
I have a comment, which is it took me a while to figure out what you meant by network configuration, network config link provider. And as far as I can tell, it's actually an explicitly specified topology rather than what you might call a static topology rather than a dynamic discovered topology.
Yes.
Correct?
Yes.
Yeah.
Yeah, it's called that because it uses the network config subsystem rather than just LLD.
It's essentially an expected state network.
Right.
Which is
I guess
We can change the name.
the name
is not.
the name confused me. But now I understand.
If you guys want to come up with a fancy name, come up with a fancy name. But it seems like a very small thing, but I can tell you that it's going to save us a lot of pain going forward. Sure, in the small deployments, it won't make a difference. But once we get larger and larger and larger, it's just going to save us a whole world of pain, because you just are that once you've got everything cabled up, it just looks right in UNOS. UNOS says, this is correct, this is what you told me you were going to give me, and this is what I have. That's going to help you. It's going to help you out in time.
You're saying the ability to configure to basically program ONUS with a static or well-known topology which is the topology that's stored in a database that corresponds to what you actually wired in your data center, and being able to verify that against what ONOS sees from its own information sources, which may be LLDP and maybe may also be configuration information from the devices or other sorts of things.
Sure. Whatever it may be.
Yeah.
We actually use this to detect the phantom link between the leaf and OBS.
Yeah,
yesterday.
Yeah.
Yeah.
It helped out, right?
Yeah.
So I mean, all these things help out. Anyway, so our goal. So we're not going to have a sprint planning on Tuesday or Monday or whatever next week, because we only have a week, and then we head off to Atlanta where we're going to build out this pod as well. So our goal next week is to really get the end-to-end traffic flowing through ACORD, and patch in all the automation steps. So every subsystem in ACORD right now has all the API required for automation, and like, you know, kind of like calling each element so that they provision their own subdomain. So we have all these. We just need to wire them together, and then we have a authentication of a subscriber will kick off that entire process and install all the flows, and we'll have end-to-end traffic in the best of worlds. So that's what we're going to aim for next week until Friday, and then we fly out, and we're Monday to Friday the following week we'll be in Atlanta building this pod. So any comments, questions, concerns for the coming couple weeks?
I have a question. This may be more like of a question for the sprint planning, but what are the biggest blocking points that we have?
Biggest blockers right now?
Yeah.
The biggest blocker we have right now is getting the set-top box set up through the tunnel that we have to UVerse, causing us quite a bit of a headache, because it's harder because the set-top box is a set-top box and it does what it wants to do. And if it doesn't get what it wants, then it gets really upset. So it makes our life really hard to deal with it. And so that's kind of the blocker to be able to test our multicast application, so our IGMP application, our multicast application, our multicast rib. We haven't been able to test them fully yet. So that's my biggest concern, I would say, right now. Other than that, you know, there's the usual concern about the OLT adaptation layer, but what are we going to do at this point, right? Any other questions, comments, concerns, worries? Congratulations? No? Anything?
Attaboys?
Yeah, exactly. Pats on the back.
High fives.
Yeah. All right. Well,
feeling a little underappreciated there, Ariali?
It's Friday and I feel sad. But all right. So if no one has any concerns about anything, then I'm guessing that we have general agreement about what's going to happen in the next 2 weeks, and everybody's on the same page. That's usually the harder one.
I have one comment. This is George. Good job, Ali.
Yeah. Thank you.
No, it's seriously great job, everyone.
Thank you. Yeah, I mean, really, we somehow are managing to pull this together somehow. It's really the, you know, I don't know how many of you have read Cathedral and the Bazaar, but this is really the Bazaar. But anyway, yeah. So hopefully the next 2 weeks will go smoothly. We'll show up in Atlanta. We'll build the pod, and it'll be so easy that we'll drink more beer than do building. All right, cool. Talk to you guys in the next 2 weeks. I guess we're going to be interacting a lot. All right. Cheers.
Bye, guys.
Bye.